Good morning, good afternoon, good evening. Welcome to Azure Community Conference 2020. 3 days, great content, amazing lineup. We are going to take a look at what is the offering from Azure in mixed reality front, an emerging technology area where Microsoft is a pioneer. Myself, Abhilash Ashok, I work as a solution architect for AR/VR at Scient. Scient is an engineering and manufacturing company. We do deal with a lot of hardwares as well as softwares. Today, we are going to take a look at two of the major offerings from Azure. Firstly, in Spatial Anchors, on how to create cross-device spatially aware mixed reality applications. And secondly, in Remote Rendering, on how to render highly complex 3D models on low-power devices like Microsoft HoloLens. Let's start with Azure Spatial Anchors. Before we get into the Azure Spatial Anchor service, let's take a step back and look at how we are creating AR experiences so far. For creating an AR experience, we always start with a marker. Marker can be an image marker, your physical object, or can even be a 3D model. What if we could take the concept entirely away from a marker and we use the real world itself as a marker, so that we get an infinite canvas to spawn our experience wherever we want? That's what Azure Spatial Anchor does. It's a cross-platform cloud service to build spatially aware mixed reality experiences that persist their location across devices over time. Before we take a look at Azure Spatial Anchor, let me roll a video. Alright, let's talk about Spatial Anchor. In its simple sense, anchor is a point of reference in your space that has a position and an orientation or a rotation. Spatial anchors means you are placing an anchor in your real world so that the anchor understands where you have placed the anchor. Now, you place an anchor in your environment and you start moving around to the other side of the point in space, then your anchor sticks firmly to it and it will not be moving at all. So that's what Spatial Anchor does. Now, what does a cloud service like an Azure Spatial Anchor helps you with? Azure Spatial Anchor allows you to share the anchor you created with one device with another devices. For example, let's say you create an anchor using Android and you want to share the same anchor point with another devices, say iOS or a Microsoft HoloLens. You can still do that by leveraging the cloud service is Azure Spatial Anchors. This enables a multi-user experience. Now, the point to remember, when you share an anchor point, you might be creating the anchor from a particular pose. And the second person who is coming to that same location need not to be in the same pose to start detecting the anchor. Instead, he can be relative to that particular anchor where you have created it, and still Azure Spatial Anchors helps him to identify and locate the anchor to start the AR experience. Let us take a very super simple video on how to create Azure Spatial Anchor. We'll also see how you can query that Azure Spatial Anchor. All right, so here we go. This is an Android application where it starts and creates Azure Spatial Anchor. So you can see that there's a create session. So once it is done, it asks you to tap anywhere to place an object. So that red marking you are seeing is what your phone is trying to understand the environment where you are. Now, we tap and place a digital object in that space. So that's a diesel engine. Now, just look at that. when you position the object and you walk around, it sticks firmly to that environment, just like a real physical object. So next, what we are going to do here is we'll be saving that anchor point to the cloud. So here we go. We are saving the anchor point. Okay, saving completed. Once that is completed, we deleted the object. So next, what we are going to do is we are going to query that same anchor point to locate the anchor and bring that digital object. So we started querying and we are looking for anchors. Yep, boom. You have your model, 3D model there. Again, it's in the same position how you have anchored previously. Fine. Now, it's not about just querying. You can also delete the anchor point whenever you want. So we'll just delete the anchor point at the end of the demo. And another thing to notice, when the camera comes to the view, your object is not flashing in and flashing out. So what I mean by that, if you have created AR experiences using image marker, when your camera is in view of the mark, if your marker is in view of the camera, then the 3D model comes. Let's say you take the view away from the marker and 3D model simply disappears. But in the case of Azure Spatial Anchor, it is different. It is not using a specific point to understand where to place a 3D model. Instead, it understands your environment. So your environment can be anything, just like a floor, a wall, or an object, like a table, what you are seeing here. And when you move slowly, the moment the environment is detected, then the anchor object is spawned, not waiting for a marker, just like in an AR experience. All right. So how does this thing work? First, you have to place an object in your space. Then you will scan the environment. So when you scan the environment, the Azure Spatial Anchor SDK, what it does is it captures the images from the environment. From that, it creates a sparse point cloud. This point cloud is converted into a hash, and this hash value is stored in the cloud service. Next time someone comes to that room with the anchor point to locate, he will be scanning the environment. During that scanning, the point cloud will be generated, and hash of this point cloud is taken and compared against the hash that is already stored in the Azure cloud. So that's how it understands your environment and locates an anchor. Now, this is how a sparse point cloud looks like for an environment, as shown in the picture. All right, so we talked about spatial anchors, where you can create an anchor and you can share that anchor through Azure Spatial Anchor. Now let's have a demo where we create anchor point from one device and we try to locate the same anchor from another device. So this is HoloLens 1, where we are going to place an object and create an anchor. So these are the various steps involved in that. We'll come to that in the upcoming slides. All right, so I placed an object, and next step is to save local anchor to the cloud. So now we are saving it. It takes some time, and it is to be noted that assume that the environment data is not enough captured, you will be prompted to capture the environment. Here we go. So the anchor has been saved. The anchor identifier is 2. So it's not stored as an integer value. This is just a representation. It is as an identifier, as a GUID. On the other side, we launched the AR app in our Android phone, and we entered the anchor number to locate. So now we are going next. Yeah, we are going to look for the anchor. So when you start trying to look for the anchor, it will first try to scan the environment and try to do a match with the cloud service. All right, there we go. We have the same cube there with the same name, anchor number 2. Now you have shared that anchor with 2 devices. You can extend this further to create a shared experience kind of experience as well. You might be wondering what are the different steps that has been shown in the demo, but we're going to cover, it's coming. Okay, so by this time you might have gone through the features of the Azure Spatial Anchors. The main thing, the primary feature, it's persistent, and the persistence can be shared across different devices. It operates at a real world scale. If you look at Minecraft Earth game, it's an augmented reality application powered by Azure Spatial Anchors along with a GPS element. Third thing, it is secure and reliable. The reason we say it is secure and reliable is in traditional AR systems, we use the actual images as a recognition. For example, let's say you create an AR experience for an aircraft engine or one of the parts in an assembly in a turbine. You want to capture an image if you're using an image marker. If not, you're going for a model tracking, you have to upload the CAD model, which is your IP protected data. And from a sensitive industries, if you're working on, you may not be okay to upload all those IP protected data. So here comes Azure Spatial Anchors, where your sparse point cloud data is generated from the point of interest, and only the hash from that point cloud data is stored in the cloud. So that way it is completely secure and reliable. Now, coming to the use cases part, you can pretty much use this for almost all the AR use cases we have used so far. But the major one being, you can create contextually integrate IoT data. Say there's a shop floor and you want to have a machinery that needs to be monitored over a period of time and take some actions, for example. Then you can create an anchor with respect to that machinery, and you wear an AR device, AR glasses or an AR device. You can see the anchor point and pull the relevant information for you, just like you use a marker. Second, you can use a wayfinding. This is something I missed to say. When you create an anchor in space by scanning the environment, you can look up for nearby anchors. Let's say you created an anchor and you got the anchor ID. You can query for the nearby anchors. So once you do that, you will be able to create a wayfinding application that will show you a path. This is typically useful when you're going to a large parking lot, especially into malls, big hypermarkets, and anywhere you want to show a route map. Third thing, you can build massive multiplayer games in the real world, just like Minecraft Earth. And since you can share the anchor point across multiple devices, you can create collaborative experiences for visualizations or any design reviews kind of experience. Okay, so let's write code. No, we're not going to write code today. Let's see what all platforms are supported. Spatial Anchors supports Microsoft HoloLens, iOS and Android with AR SDKs. You can build the applications using Unity 3D, or if you want to build native applications, then of course you can write C++, Binati for HoloLens, and Objective-C Swift for iOS, and Java or C++ /NDK for your Android devices. Now, how do you set this up? Log into Azure, search for Spatial Anchors. Once you're done, create a Spatial Anchor account by entering the resource name, selecting the subscription, resource group, and the location. Next, once the account is created, you have to copy your account domain and account ID. Along with that, you will also have to copy your access keys. You'll take this account domain, ID, and access keys into your Unity project and enter into the APIs where the SDK is expecting those values. Once you're done, you're good to go. Okay, now while seeing the first demo, no, not the first demo, the shared experience demo, you might have noticed that I clicked through different buttons that is saying next to this, next to that. So what are in fact those? These are the various steps in creating an Azure Spatial Anchor. Now, coming to the authoring side, this is typically where you use a marker in your traditional way to select the marker and generate the package that you usually import into the Unity project. So similar to that, you need to have an authoring experience within the same application, not outside the Unity, where you enter your Azure Spatial Anchor ID, domain, and key. Then you will create a Azure Spatial Anchor session. Once that is created, you will start the session. Then once your session is started, you are good to go to create an anchor. It is to be noted that you can set an anchor, you can set an expiry for your anchor. Once you're done, you can place your digital content. Once your digital content is precisely positioned, then done. You can save your anchor, you can close your session. You're good to go. Coming to the end user side, they launch the application, sessions are automatically created, then its session is started. Then of course it will look for the anchors. Once it is located, you can start the experience, or you can query for nearby anchor in case if you are building a wayfinding application. And yes, like an AR experience, you can perform the activity or task what the application is designed to do. Once you're done, you can close the application. It is to be noted that you don't need to create or follow all these steps one by one, just like you have seen in the demo. You have events available in the Azure Spatial Anchor SDKs that triggers an event when a session is created, when a session is started. So you can transparently wire up all these steps inside that, so that when the end user launches the app, everything happens in background, and you can immediately prompt a text saying that, hey, look for your anchor, or something similar. Now, Azure also gives you an option to see the metrics on how many anchors are created, queried, deleted, and pauses found. So you can create your own metrics. All right, you want to know more? You can get to the Microsoft Docs, as well as GitHub samples are available where you can download and play around with it. Okay, I think that's all about our Azure Spatial Anchors. Let's see what Remote Rendering has to offer here. Azure Remote Rendering. Azure Remote Rendering is a cloud service to render highly complex 3D models in real time on devices, specifically on low power devices or untethered devices like Microsoft HoloLens 2. So why you need a service like a remote rendering? Imagine you want to render a high poly 3D model, and the untethered device you will be using, let's say any device you pick that is untethered, that will be having a low computation power. You won't be able to load a high fidelity 3D model within its original quality. So in this image, you are seeing a model that is having 18 million polygons. We'll see the actual model in HoloLens in a while. Now, what happens when it has been downscaled to render it on untethered devices that don't have much computation power? You'll have to decimate to a greater extent. But problem with decimating is, beyond a point, it will start deforming, it will lose its structure, it will lose its shape. So this is how the model looks like when you decimate it to a 20K triangles. Let me show you a very simple demo on rendering the same 18 million polygon model in a HoloLens 2. Now, point to be noted that this is a mixed reality capture, so you'll not have the same 2K quality which you visualize through a HoloLens 2. The experience and the quality will be slightly degraded, but rest assured, when you use the device, it is high quality. Now, so we are launching the application. Once it is launched, it will start a remote rendering session connecting to the Azure cloud. So the session status is ready. So you can see the different stats coming in. The model is not yet loaded. Yeah, 60% loaded. Rendering is at 30 frames per second. We'll come to that 30 FPS in a while. And you can see the rest of the stats like the GPU utilization, memory utilization, and polygons. All right, so this is the model. But this model looks really, really beautiful in the HoloLens 2. This is just a mixed reality capture. Yeah. Okay. So we brought the same model here, and I just positioned it so we can just walk around the model. Yeah, you are seeing some gaps there, but in fact there are no gaps when you look through the HoloLens 2 device. So I'm just looking into the model, and you can see the internal structure. Okay, I think, yeah, we're done. So here we go. Now, take a look at the stats that has been displayed there. It is rendering at 30 FPS. The reason why it is rendering at 30 frames per second is we are recording from the device. At the same time, the device is connecting to a remote rendering service to stream a high quality 3D model. And you can also see the drops in frames, the latency, the CPU utilization, the GPU utilization. So APIs are available to pretty much to understand how your streaming quality is. And I forgot to mention, you need a pretty good bandwidth to stream this at 10, somewhere to 10, 12 Mbps should be good enough to have a full streaming. Now, imagine I'm not going to record this. In that case, just look at this. My model is in fact rendering at 61 frames per second. You're going to believe that? Polygons is an 18 million polygons rendering at 61 frames per second. That's impressive. No questions asked. And this is one image that I captured when I was not recording. So just to show you that the difference between the capping, why there's a 30 FPS in the demo and in the recording, and in actual it always stabilizes at 60 FPS. Okay, so how this works. What Azure Remote Rendering does, it offloads the rendering workloads to a high-end GPU in the cloud, which means rendering of your high poly 3D model will be happening in the cloud. Yes, of course, you'll have to upload the models to the cloud into the blob storage. Then there's a dedicated graphics engine that renders the image. So all these models will be converted into the image from different angles, and the images are encoded into the video streams. Yep, so you got that. You're rendering in the cloud, converting that into images. Then this is finally encoding into a video stream, and finally streams to a device like HoloLens. That's good. But it doesn't stop there. Just because your 3D model is rendering in the cloud, the service will also make sure that the head pose of the user is synced with the pose in the remote rendering service, so that there won't be any lag. It looks quite natural, and it also uses a late stage projection by predicting where you are moving next. Obviously, there will be one doubt we'll have in our mind. Oh my God, if you're dealing with video streams, how can I interact with it? Can I interact? Can I manipulate? Can I do a zoom in, zoom out, explode, cross-section? Yes, you can do all the manipulations and interactions. You have APIs readily available for that. And we're going to take a look at that. Not now? Yeah, it's not now. Okay. So these are some of the features that are powered by Azure Remote Rendering. You get a section cut, which is also called as a cross-section feature. Then you can do a tinting of a particular part with a color of your choice. Then you can also create a see-through. We always call this as an X-ray in our regular VR project, I guess. You can do outlining, and you can do PBR rendering that allows you to have a real-life rendering of the 3D model. Of course, you can do sky reflection. And there's a lot more features that are available out of the box, which you can really try it. So next, we will take a demo. We'll take a look at the demo for almost all these features. Let's see. Okay, so we are going for an explode. So now the same 18 million polygon 3D model has been just exploded. If you have noticed, I just put an air tap just around the model, so its interaction and manipulation is pretty much covered. Yeah, so it is exploded into its bits and pieces. And even when you look through it, you just have a look. Okay, so we are resetting it back to its original form, and next we will try with moving individual parts. Okay, selected and part from that assembly. Okay, so now I am moving each individual part. Okay, so we did a reset. So next we will have a look at section cut. So I just made that section cut part a little bit big. Now I'm moving it to a part. Yeah. Then moving it through the cursor. So you can see that the cross section part, it is happening. Oh yeah, that's beautiful. Like I said, the quality is really great. This is an immersive capture, so that's why it looks like kind of, yeah. Okay, so next, you can even hold the cross-section UI with your fingers, and you can just move it. So it's both way it is possible. Either you can use the point gesture. Okay, so next we'll see how you can apply colors to a certain part, the 3D model. Okay, yeah, that is going to change. Yeah, that changed. And we change the color, and we'll change color for one more part there. So it is to be noted that what all changes that you're making here is synced back to the model that is running in the cloud. Yeah, so you can also set lighting, different lightings to the model. Okay, I think, yeah, we are done. Okay, as on today, it supports HoloLens 2 and desktop application. You need to create a UWP application. Standalone versions are not supported. And coming to the 3D model formats, you can use either FBX or GLTF or GTB. FBX should be your version 2011 and higher, and GLTF or GTB should be v2.x and higher. It works as universal render pipeline, which is a recommended pipeline, and a standard render pipeline. And at the moment, no VR devices are supported. So how do you create it? It's pretty much a straightforward how you create an ASA. You can head to Microsoft Azure portal, search for remote rendering, then create a remote rendering account, enter the resource name, subscription, resource group, and location. Once you're done, your account will be created. Next, you will have to copy your account domain and account ID. And yes, of course, you'll have to take the access keys. And then you go to your Unity project where we import the SDK and set these values so that you can start talking to the service. Coming to the use cases, since you can render really high quality 3D model, you can use it for architectural visualizations or design reviews, and you can even have large outdoor maps. Data doesn't matter at all since it's rendering in cloud. You can have your previewing your photogrammetry models, and you can have compact machine visualization. Okay, for more details, you can refer this link. All right, so that's about the Azure Spatial Anchors and Azure Remote Rendering. Thanks for the sponsors and the communities who help power Azure Community Conference 2020. And there's Schema. I was part of that. I mean, I am part of that still. All right, thank you for your real time. It's question time, so let me start taking questions.